This lecture is on inequalities between triangles and within a triangle. So starting with this principle here, if one side of a triangle is longest, then the opposite angle to this side is the largest. So this side angle's the biggest, this side's the biggest side, then this angle's the biggest angle. Also, the angle opposite the shortest side is the smallest. So if this is the shortest side over here, then here we have the shortest angle on the left. So shortest side BC, shortest angle, or smallest angle, angle A. So basically biggest opposite biggest, smallest opposite smallest. Here's a sample problem. We have our three side lengths, and we know the perimeter is 90. We want to list the angles from smallest to largest. So let's first find out the side lengths. So we've got 37 minus x plus 2x minus 16 plus x plus 13 is equal to 90. And I can cancel these guys. I get 2x plus 50 minus 16 is equal to 90. Let's get rid of that, make this 40. 2x is equal to 56, so x is 28. Plugging back in, 37 minus 28 is 9. 28 plus 13 is 41. And 56 minus 16 is going to be 40. So the smallest side is the 9, therefore angle U is the smallest one. The next smallest side is the 40, so that means the next smallest angle is angle S. And then finally that's smaller than the biggest angle, which is angle T, because that's opposite the biggest side. So smallest angle opposite smallest side, biggest angle opposite biggest side. It works both directions. So if you have a large angle, then the side opposite is the largest. If you have a small angle, the side opposite is the smallest. So this idea goes both directions. Okay, this time we're given angle measures algebraically. We want to list the sides in order from longest to shortest. So let's find these angles. Well, last time we were given a perimeter. This time we're not given such information, but you don't need it because you do know that in every triangle there's a total of 180 degrees measure. So 7 and 9 is 16 and 12, so 28x, and then 26 and 11 is 37 plus 3 is 40 equals 180. I'll divide everything by 4, do it that way, and that's equal to 45. So 7x is equal to 35, x is 5. Plugging back in, this will be 48 degrees, this will be 71 degrees, and this will be 61 degrees. And so the biggest angle is the 71, so the biggest side is KL. And the second biggest angle is 61 up here, second biggest side KJ, and smallest angle is 48, so smallest side is LJ. Okay, this can get a little bit more interesting. First, we'll just look at a couple more basic ones. Largest and smallest angles. Largest angle would be angle E because it's opposite the 7. Smallest angle, angle F because it's opposite the 4. Largest angle is opposite 8 because it's the biggest number. Smallest angle is angle R because it's opposite the smallest number. Looking at the other direction, we know there's 180 degrees in a triangle, so if this is 15, this is 130, then this is going to be 35 degrees. Biggest side is going to be over here, smallest side over here, because you go opposite the biggest angle for the biggest side, smallest angle for the smallest side, and so on. Now when we have more than one triangle, it can get a little bit trickier. And so in this situation here, we want to find the longest and shortest sides out of the entire figure, and you can't compare angle measures from one triangle to another. You can't compare, say, the 45 and the 80, 60, 70. It only works one triangle at a time, but there's a way to match things up. So first let's find these missing angles. So this is 105 together, which is going to make this 75. So obviously this is not drawn to scale. These are 70 and 80. That's 150, so this will be 30. So now we list them separately. In triangle ABC, the longest side is going to be side AC because it's opposite the biggest angle. The next biggest one is BC, or CB, because it's opposite the 60, and the smallest will be opposite the 45, so that's AB. And now looking at triangle ABD, the longest is AB, because that's opposite the 80. Next biggest is AD, because that's opposite the next biggest angle, and the smallest is opposite the smallest angle, so that's BD. Now the thing we notice is that AB is of course equal to itself. And so if AC is bigger than CB and bigger than AB, and AB is bigger than these, then the longest one overall is that side, and the shortest one overall would be that one. Sometimes it doesn't work out that you can find out exactly how they rank, but because the smallest of one was the largest of the other, you can do that. And again, we can look at this from the opposite direction now. This is, now we're given sides and we want to list angles from largest to smallest. And so we have to do it separate triangles again. You can't compare, say, the 20 in this triangle with the 12 over here. You have to do it individually. So top triangle, the largest angle will be angle B, because that's opposite the biggest number in that triangle. Then we have angle C, and then angle D, or to be a little bit more exact, angle BDC. Now for the lower triangle, triangle ADE, biggest side is here, so biggest angle is angle ADE. Next biggest side is 18, opposite that is angle E, and finally opposite the 16 is angle A. So again, we note that these are vertical angles, so they're congruent, and therefore these are the same, and so the biggest angle overall will be angle B because it's bigger than both of these, and because these are congruent, we know that if you're bigger than these two, you must be bigger than these two as well. So this is the biggest angle of all, this would be the smallest angle of all. Okay. The other part of this particular section is called the triangle inequality theorem. Triangle inequality theorem. And the idea is that for any triangle to exist, two of the sides must be greater than the third side. The sum of the lengths of any two sides of a triangle is greater than the third. So in this triangle here, we know these three side lengths can make a triangle because 5 plus 12 is bigger than 15, 5 plus 15 is bigger than 12, and 12 plus 15 is bigger than 5. In actual practice, to check to see if this works, all you really need to do is just check the smaller two sides, make sure they're greater than the biggest one, because you know if you take the biggest one and add, you're going to be greater than a different one. So all you really need to check to be sure is just the smallest two, and it's not good enough to be equal to. You have to be greater than. Equal to is not sufficient. So can a triangle have these side lengths, 4, 8, and 6? We take the smallest two, 4 plus 6, and that is greater than 8, so that would be yes. Over here we take the smallest two, 2.6 plus 4.1, and that's equal to 6.7. It's not greater than, so the answer is no. You have to be greater than. Okay, one other way to look at this is now, instead of being given three sides and say, can these make a triangle, we're given two sides and saying, how big or small can the third side be? So let's say two of the sides are 4 and 7. What's the biggest or smallest that third side can be? So we use the triangle inequality theorem that says that any two sides must be greater than the third, so 4 plus 7 must be bigger than x. So therefore x must be less than 11. This side cannot be bigger than 11. Also, we can say 4 plus x is greater than 7. We subtract 4, so x must be bigger than 3. So we know so far we've got to be less than 11 and bigger than 3. Now let's try x plus 7 is greater than 4. We subtract 7. X is bigger than negative 3, but that doesn't tell us anything because we already know we have to be bigger than 3. So basically we're between these two. So our last side must be between 3 and 11. It can't equal 3 and 11. It must be between the two of them. For 7 and 16, do the same thing. Add 7 and 16. Must be bigger than x, so x is less than 23. Try 16 plus x is greater than 7. That one doesn't tell us much. It's negative. Flip it around one more time. 7 plus x is greater than 16, so x is bigger than 9. And so therefore, you're bigger than 9, less than 23, so you're between 9 and 23. So the shortcut to this, because there is a real easy shortcut, is all you got to do is subtract the numbers and add the numbers. 4 plus 7 is 11. 7 minus 4 is 3. 7 plus 16 is 23. 16 minus 7 is 9. Here's sort of a general formula that you add them and then you subtract them, the absolute values, so that we don't get these negative possibilities. So a little bit more practice with that. If you're given 4 and 7, then you know that last side must be between 3 and 11 because you add them and subtract them. If you're given 11 and 20, see, subtract them and then add them. 5 and 5, subtract them and then add them. 6 and 8, subtract them and then add them. Just like that.